I'm JK and my channel is JK Solutions. This video is about uninterrupted electrical distribution with ATS. ATS meaning automatic transfer switch. Conventionally, when there is a changeover from the mains power supply to the generator system or vice versa, there is always a blackout that characterizes the period of changing over. It is that blackout during the changeover system that I want to eliminate in this video. I'm going to show how a design can be done and the installation can also be done to eliminate that kind of blackout. You know, even if it is a automatic changeover system, there is always time that is taken before the changing over is totally achieved. It is that blackout that conventionally usually characterizes the changeover at the period. So that is what I want to eliminate in this video. Please follow me in this video. Meanwhile, please, if you are yet to subscribe to my channel, JK Solutions, please do so. Meanwhile, I will use an example to illustrate the concept for clear understanding. Please follow me. So here we go. Example. The power requirement of a particular hotel located where supply voltage is at 11 kV 50 Hz is 210 kVA. The questions are: A part, determine the delta star 50 Hz transformer and generator sizes for the hotel. B part, hence or otherwise draw uninterrupted electrical power schematic diagram for the hotel. Neglect transformer losses. Yes, the transformer losses could be neglected because the total loss, when all the losses added together, they are minute. Yeah, what we are saying here is that there are places where people cannot afford to have the transient blackout during the changeover period. A place or places like hotels cannot afford to have a blackout at all, and that is why this video is going to explain how the blackout can be eliminated. Please continue to follow me. Solving the problems. A part, the transformer size as given by the question. The transformer is delta star at 50 Hz frequency. So the total hotel load is 210 kVA. So the transformer size is 300 kVA. 300 kVA is higher than 210 kVA, and it also takes care of the future incremental load group. So similarly, the generator size is 250 kVA, some-proof generator, 400 volts line to line at 50 Hz. Moving on. Now, a solution to B part. In order for us to be able to sketch, to draw the uninterrupted schematic diagram for the hotel, we need to know certain things. The first thing is that since the schematic diagram is going to be uninterrupted, then we have to introduce UPS, uninterrupted power supply unit, here. So the size of that one is also equal to 250 kVA. Alright, now let's calculate the load current. For star connection, I phase is equal to I9. So as I mentioned it in one of my previous videos. So the load I phase is equal to the load I line, which is equal to 210,000 VA divided by root 3 times 400 volts, and that is equal to 303 ampere, triple phase with neutral. It doesn't mean that the neutral current is 303, as I always mention it. So it only indicates that neutral is part of the system. We are having 4-wire system, 3-phase 4-wire system. So, and from here we can determine the main MCCB to be 320 triple phase with neutral. So since this is the next available MCCB, that is model case circuit breaker, so the UPS size is 250 kVA. It has to be slightly greater than the load requirements, or the power requirements rather. So we move on. Now coming to the schematic diagram, as I said, in order to eradicate the, or to eliminate the blackout during the changeover period, whether manual or automatic, in order to eradicate the blackout, we need to introduce the UPS here. So let's start from the incoming section from the mains. This is the main. Generally we have 3 parts: the mains part, or the main side, the generator side, and the load side. So we start from the mains side. So here we have the transformer 11 kV, the primary winding being connected in the delta. Then we have star here for the secondary winding. So from here we go to the energy meter. So from the energy meter we come to the CM. CM here means contactor for the mains supply. So when we, in order to have an automatic transfer switching system, it is easier to use a contactor, or we can use a motorized circuit breaker. But in this case, I'm choosing to use a contactor. So the contactor current rating is 350 amp, triple phase with neutral, or it is 4-pole contactor. All right. Then we have this instead of the conventional MCCBs, we are having 2 contactors, one from the generator system and the other one from the mains. So they are now linked like this, and it is this link that is called the ATS, automatic transfer switch. When this contactor is energized, this one is the energized. When this one is energized, this one is the energized. The 2 of them cannot be energized at the same time. All right. So we move on. So the mains delivers power to this common bus section, and from here the power enters the UPS. Okay, the uninterrupted power supply unit receives power. So from here it goes into this panel, which is the load panel. It's LV, low voltage panel. It's MCCB panel anyway. That is the meaning of P means panel. So we now go to the generator side. We have generator 1, generator 2, because in a situation where one generator is faulty, you need the other one. The other one should be in place. That's why 2 generators are required. So, and then from the ATS panel we have this signal line, or a combination of signal lines coming here with a changeover, with a changeover switch here, as to whether you want to select generator 2. This is generator panel 2, this is generator panel 1. So you select one, at a time. So now from here we have the mechanical interlock here. The two generators are not working at the same time. One is on duty, the other one is on standby. Alright, so from here we go to the contactor for the generator. So and they are linked together, making use of this ATS. So when this one is energized, this one is de-energized. The two of them should not be energized at the same time. This one energized, this one de-energized. So if this one is energized, this one is de-energized. So from here, let's say the generator, if there is failure, the mains failure, so the generator output continues to be here. From here, it will still come and enter the UPS, from the UPS to the load panel. So actually the flow of power for the two sides is like this, from here through the meter, that is the mains, through this contactor, through this bus section to the UPS, to this circuit breaker, and to this load bus section. So even for the generator also, the output of the generator comes here. From here it goes into the contactor for the generator, and the power is delivered to this common bus section. From here it goes through the UPS as well, because normally this circuit breaker here is left open because it's serving a different purpose. So this one is open. The interlock is adjusted in such that, or is operated in such that it's only this circuit breaker that closes. This one opens, this one also opens. Where these two circuit breakers become functional is when the UPS has problem. If the UPS is faulty, instead of removing it, there's no room for blackout. So instead of in order to create time for its removal, so this one will be closed, this one will also be closed, this will open, and this one will open, so that the UPS can be removed. So and the power flows from the generator through this place to the load. Alright, and to the generator, even the, assuming it's the main, even if it's on the mains also, and the UPS is faulty, the mains delivers power to this common bus section. So from here the UPS is bypassed through this circuit breaker and this circuit breaker, and that is the function of these two circuit breakers. That's why I call this one UPS bypass. So that is what is doing there. So we now have the loads. The magnitudes of the load will determine the sizes of this circuit breaker. We can have more than 3 outgoings. So for instance, each of them could be going to sub distribution panels or to distribution board, as the situation may require. And that is the end of the solution to the B part. So finally, please do subscribe to my JK Solutions channel. Thanks for watching.